Alrighty, good morning, everybody. Let's get started here. It's a minute or two after 12. Have a lot of slides here, probably too many, but want to try to give you as much information as I could in basically an hour. My name is Jim O'Donnell. I work for HC&I. I'm a sales engineer. My contact information is the lower left-hand corner for my cell phone and email. Just thank you all for signing up for this seminar or webinar, I should be calling it. This is the first of 3 parts. What we're going to do is we're going to mute the attendees to try to streamline the process. We'll ask to save the questions until the end of the presentation. And then at that time or during the presentation, you can type in your questions and then we'll answer them. We are going to record this presentation. We can provide a copy if you wish. We can issue PDH credits 1.0 for this presentation. And then, lastly, just want to thank my coworkers at HC&I for helping me out with this presentation, but then especially for Tim Green, Buck Nye, Rick Aditis, and then also Jim McCloy. All right, so let's get started. All right, so today is part 1 for our fall seminar series. As the slide says, we're going to look to improve indoor air quality during replacements and retrofits. And then, as I mentioned, this is part 1. Today, we're going to focus on filtration and source control. All right, okay, there we go. All right, so quick agenda today. I'm just going to quickly review indoor air quality concepts 101. We're going to review the recent ASHRAE epidemic publications. Once again, we're going to emphasize filtration and source control. And then we're going to take those publications and try to apply them for some system applications for replacements and retrofits. And today is primarily going to be focused on retrofits. All right, so indoor air quality consists of 3 parts of the triangle in the upper right-hand corner. You have filtration, dilution, and source control. We're going to talk about filtration, which is basically filtering, cleaning of the air. Source control is sort of, self-explanatory. All right, so what is in air is 2 broad categories of aerosols and gases. Under aerosols, we have pollen, viruses, microorganisms, dust, etc. like that. So aerosols would be considered to be fine particles in the air. Part of those aerosols are microorganisms. What we're going to be focusing on or concerned today are pathogens or items that do cause disease. And there's 2 types that we're going to look at: bacteria, and then obviously emphasize on viruses. This is a chart that just wants to give an indication of particle size in the upper left-hand corner. On the left, you have the approximate size of hair, and then I've circled on the right, you have the approximate size of viruses. Just the diameters or the widths that we're talking about today are microns. 1 millionth, 1 micron is equal to 1 millionth of a meter, and then if you're the metric haters, there's what it is for the inch. And then just to understand a size comparison, you have a human hair that's approximately 40 to 120 microns in diameter. Naked eye, what you can see, obviously age dependent, is approximately 40 to 60. And then when we're looking at viruses, you really need a electron microscope because they're 0.01 to 0.3 microns in diameter. And then just, as recent events everybody's aware of, there's a SARS-CoV-2 virus that's a new coronavirus that causes the coronavirus disease, which is also known as COVID-19. And then just at an approximate or average size of the SARS-CoV-2 virus is 0.125 microns in diameter. So obviously very, very extremely small. So how do viruses spread? This is once again very basic information. Just viruses reproduce by using a host cell's DNA to manufacture clones of themselves. Found on the internet for Ebola, but just looking in the upper left-hand corner, the virus attacks the human cell it ends up replicating itself, and then it then produces or releases back into your system. Ways that viruses spread are listed down here on the left. Contact, indirect contact via blood transfusions, bodily fluid, water, feces, and animals, and then just throughout the word vector-borne as a help to all you Scrabble players out there. All right. So now also viruses are spread by airborne. Upper right-hand corner shows a person that's sneezing, could be talking, could be singing, etc., like that. And then this slide is from a tuberculosis showing how infectious droplets spread. If you have an infected person that ends up coughing or expelling the virus, the larger part A is the large infected droplets where they're encased in water. A little bit further away, the mucus / water that's surrounding the virus starts to evaporate. And then eventually, or some of those B also turn into item C, where there's no mucus, water covering, and that virus can float in the air. Now, obviously, once again, we're talking about or interested in SARS-CoV-2. I just put a question here about airborne transmission. I saw a few weeks ago that the CDC said that it's airborne, and then quickly a few days later, they reversed course on that. And then I think I saw something earlier this week that they are saying airborne. Once again, I've to be honest with you, I've kind of tuned out some of the COVID stuff just because there's so much literature in the or information in the media. So anyway, part 2, we're going to talk about the recent ASHRAE epidemic publications. We're going to emphasize filtration and source control. They have 2 publications. One is building readiness, with those dates there. It's been updated a few times. And then also schools and universities. All right, so ASHRAE, I'm sure everybody's aware of, Heating Society of Refrigeration and Air Conditioning Engineers. They've created an ASHRAE COVID-19 website, and they've also created an epidemic task force. Now, they have a statement in there that says ASHRAE's position is that the transmission of SARS-CoV-2 through air is sufficiently likely that airborne exposure to the virus should be controlled. All right, so changes to building operations, including the operation of heating, ventilation, HVAC systems can reduce airborne exposures. All right, so ASHRAE has taken the position that more than likely, once again, the virus is spread by airborne exposure, airborne transportation. All right, so just looking at these 2 documents, the first one, building readiness, it's over 100 pages long. It was initially published May 21st. They issued an update in August, and then a second update in September. To be honest with you, I looked at the September versus August update, and I could not find any differences. The schools and university is 41 pages long. That was issued in July. I've heard that they just recently issued another update on that, in the last day or 2. But to be honest with you, it just came out too late to change all my slides for today. Other thing that the epidemic task force came out with is that cool looking emblem or symbol in the upper right hand corner. All right. So this is a quote from one of the standards or documents rather. These are guidances. It has been formulated to help designers retrofit and plan for improving of IAQ and to slow the transmission of viruses via the HVAC system. Once again, just want to emphasize that this is guidance. It's not code. A lot of it is open to interpretation. All right, and then paraphrasing from the 2 documents. These documents were intending to kind of be all-encompassing. They're to be applied for each different climate zone, building, zone within your building, and HVAC system. They're for designers, owners, operators, technicians, etc. And then it also is to be applied prior to, during, and then also post operations. All right. So the building readiness has 2 broad categories. The school and universities has other broad categories. I'm not going to read each one. Just in my opinion, the schools and universities, I've highlighted it. In my opinion, that document, that publication is a little bit more practical, or just has more information that could be applied to our HVAC industry for specific applications and operations. All right. So from the building readiness, specific recommendations that they list, these are quotes: increased filtration, increased ventilation, increased filtration, energy recovery system operation and considerations. And then the fourth thing is building exhaust re-entrainment. Entrainment, once again, is a good Scrabble word there if you start with train. So anyway, today we're going to focus on increased filtration with filtration and source control. And then, as I mentioned previously, we're going to talk about replacements and retrofits, but really primarily the topic today is going to lend itself mostly to retrofits. All right, so digging down into the two publications for building readiness under epidemic conditions in place, I've highlighted two items. One is upgrading and improving filtration. The second one is UVGI systems. And then under schools and universities, they have a designer guideline, dash for general school. And then they also have a significant or detailed section about filtration upgrades. So with the two publications, basically they have three sections or three parts here where they talk about filters or filtration. And then they have one section, it's really one page, where they talk about UVC or UV lights. So paraphrasing from the two documents, looking at filtration, number one, ASHRAE recommends to apply the highest mechanical filtration efficiency applicable for HVAC units. I've highlighted just local, central, and DOAS units. There's a couple pictures there of a vertical fan coil, a central air handling system, and then a rooftop unit that could be also considered a DOAS unit. And then part two, ASHRAE recommends that the efficiency be at least MERV 13. MERV stands for minimum efficiency reporting value, and preferably MERV 14 or better to help mitigate the transmission of infectious aerosols. All right, so why did they pick MERV 13 plus? All right, so this is a very well-known, common chart. It was actually published in one of the standard or guidances. And what this chart is basically is have your MERV rating from 1 to 16 on your left, and then they have different particle sizes with 0.03 to becoming larger on the right. And then our chart here shows the composite size efficiency of how many particles would be removed. And so I've highlighted just MERV 13 and 16. And then also I've highlighted just the small microns of 0.3 to 1.0. And then the other thing I just want to point out is in today's discussion, we'll talk about HEPA filters. And just HEPA filters are not on this chart, but HEPA filters are the next level greater of filtration, where instead of MERV 16 has a 95% efficiency, HEPA filters have an efficiency of 99.97%. All right. So this quote is from the standard once again. It says MERV 13 and greater filters are better at removing particles in the 0.1 to 1 micron diameter size. And then it says parentheses, the size of many virus particles. But then they have a little catch-all, hey, be careful. They say the higher efficiency does not come without a penalty. All right, so a little foreshadowing or a little warning there. All right, so what is the penalty of higher efficiency? Filter efficiency, sorry. So the standard, once again, quoting right from it, higher filter efficiency requires greater air pressure to force the air through a filter, all right? So depending on your face velocity, your range of air pressure drop through filters is, for existing filters, MERV 8 is probably or is definitely the most common type that has been installed. So when the filter's clean, the air pressure drop is approximately, an 1/8 of an inch. And then as the filter gets dirty and increases its resistance, that filter then has a higher pressure drop of approximately in the 0.5 range. Now that was MERV 8. Now they want you to upgrade your filter to MERV 13. Now, the problem with this, or just the understanding with this higher efficiency filter, is that it's catching more particles. It's going to increase your air pressure drop. So typically, when the filter is first installed, it has an approximate air pressure drop when it's clean of 0.3 water gauge. And then as the filter gets dirty, it could be up to 1.25 inches. Once again, there's a lot of different information here, or just information available about different filter manufacturers, different filter depths, and then also different filter air pressure drop. But just essentially, you're kind of in trouble. It's like you have a higher air pressure drop where you're going to have approximately a 1/2 inch to a 3/4 of an inch additional airflow, additional air pressure drop. And then, as we all know from HVAC, higher air pressure drop results in lower airflow. Now, the problem, now you're starting to continue to exacerbate your problems here with your system. So lower airflow is going to translate to lower system capacities. So are you going to be able to maintain your indoor temperatures? Are you going to be able to maintain your indoor humidity relationships? You got to be careful about pressure, your space pressure relationships. And then the other thing that is going to take really a backseat because we're talking about IAQ today is that higher air pressure drop is going to result in higher energy consumption. All right. So now the thing I just want to really try to emphasize is that you got to be careful if you're going to affect your indoor temperature and indoor humidity levels. Doing those obviously increases your problems with comfort control, but then also too, you're sort of defeating the purpose of improving your indoor air quality by having your humidity levels too high, where you can produce mold, or too low, where you could have problems with dryness. All right. So your ability to evaluate your increase in filtration. All right. So what the standard, these are kind of paraphrasing. I'm trying to summarizing what the standard is saying. What they want you to do is collect and record data on all the existing equipment. So what that encompasses with your existing equipment is you should look at your heating, cooling, and dehumidification capacity, your airflow, your total static pressure, your fan performance. For your filters, what's your MERV rating? What is also the thickness? And then can the existing filter rack accept a thicker filter? You should look at the type of and size of your fan motors as well as VFDs. And then you should also record your electrical service, related to your refrigeration circuit, but related to equipment for your MOC and MCA ratings. Now the difficulty is okay, you can get your design data maybe from your original design documents, or if you're lucky enough to have as-built drawings, but then also too, what is actually your actual existing operation? This becomes sort of a delicate sort of balancing act, or a tricky situation to kind of make some assumptions on. All right. So now the standard also talks about or suggests you consider hiring an air balancing company or person to perform and document. They're calling it a complete static pressure and temperature profile of the equipment. A little bit kind of weird terminology. And then they're asking you to maybe, or to consider looking at doing that for your existing equipment, and then also doing that for your proposed filter, your upgraded filter. Excuse me. So just diving into what static pressure profile is. What they want you to do is record your airflow, your fan energy, your RPM, et cetera, like that. Next step would be to evaluate and say, how does the increase in air pressure drop from the higher filtration affect the loss of airflow? And then, as I mentioned before, you want to look at your existing fan system if it has enough spare capacity to accommodate the additional pressure drop. And then if there isn't enough fan performance left over, is there enough space within the unit to change the motor/fan assembly? And then the next part is, if you put in a larger motor horsepower, is this going to change your electrical service? Now, part 3B is air temperature profile. As you can see, these are, once again, would be done in conjunction. These, the 3A and 3B are related. So first you would record your temperature, humidity, capacities, etc. And then once you have that information, you would perform like an evaluation of is your existing capacity large enough for your low, acceptable at these lower airflows. All right. Okay, so summarizing, once again, to increase your filtration, you want to gather, record, you want to evaluate. Third, you want to maybe do field testing, and then it warns about causing temperature and pressurization problems. All right. So part 4, after you've done that, is what work can be implemented on your existing capacity for your hydronic cooling, heating, your direct expansion systems, gas heat and electric heat. And then the other thing that we'll look at is not just capacity, but we'll also evaluate or just look at filtration of your actual equipment. We'll look at air terminals, air handlers, and then 2 different types of packaged rooftop units. All right. So first, looking at the capacity of your existing systems, these are just general observations. If you have a hydronic cooling and heating system, this more than likely is your most flexible opportunity to improve your capacity. You can increase your flow or raise or lower your temperatures, but obviously you'd have to evaluate your central cooling capacity, your pumping, as well as your distribution system. If you have an existing DX cooling system, more than likely this is probably inflexible. You can change slightly your operation by adding refrigerant or changing refrigerant temperatures, but more than likely if you have a 10-ton system, you're stuck with the 10-ton system. If you have gas heat, I would consider this to be very inflexible. More than likely you cannot change. When the product comes from the factory, there's a UL/AGA certification. If you do any modifications in the field, you should have those coding or officials come out and recertify your equipment. And then electric heat is not common, but it is out there. So more than likely this is inflexible. If you have to increase your electrical heat, you might have to increase the size of your electrical service. All right. And then obviously the larger your system is, the better your chances of being able to change things. All right. So next we're going to look at, go through equipment. We're going to look at capacity and filtration. Once again, these are general observations. Obviously you would have to evaluate on a case-by-case basis. For terminal units, which I'm going to lump as fan coils, unit vents, water source heat pumps, VRF, etc., these are generally poor candidates. They're small. They have 1-inch or 2-inch low efficiency filters. They don't have much fan energy. And they typically have 3 or 4 rows of cooling and heating coils and not much available. A little bit better candidate would be a central station air handling unit. Typically they're larger in size, they have more space inside of them. Oftentimes they already have filters that are greater than 2 inches in depth. You have the ability to swap out coils. They're modular construction, so maybe you can take out a section and put in a bigger section, and then also too, once again, you have, fan motors are generally larger, so you have a better opportunity to effectively change something. All right, continuing on to package units, I'm going to consider these as kind of, pre-engineered, coming straight from the factory or maybe in stock. These are generally less advantageous. Once again, they're lower in fan capacity. They're typically, tight. Not much space inside them. More than likely they have just 2-inch thick filters. Now, if you have an applied rooftop unit or DOAS, you have a little bit more advantageous, or you probably have a better opportunity to change things. Typically, these have higher static pressures. There's more space, but especially more than likely they have filters that are greater than 2 inches of thick. All right, and then once again, for the equipment, a larger equipment, but then also newer equipment, you would have a better chance of success. All right. So now on ASHRAE schools and universities, they have, if MERV 13 filters cannot be installed, what do you do? All right. So consider the following. These are quoted right from the standard, or from the, I'm sorry, I keep on calling it the standard publication. We're going to increase the filtration to the maximum available. I've highlighted in red, consider UVC treatment, provide a recirculation fan filtration unit, provide a HEPA filtration unit which recirculates the air, and then there's some other items. But the one item I want to focus on or just emphasize is they also say consider air ionization systems. Now in the building readiness, they mention the word bipolar ionization, and then they also mention needlepoint bipolar ionization. All right, so now let's look at needlepoint bipolar ionization for how it can be applied to help satisfy the standard. So just information 101, ionization is a process by which an atom or molecule acquires a positive or negative charge by gaining or losing an electron. Ionization uses an electromagnetic charge to create a electromagnetic field, and then as the air passes through that field, which has been created by the charge conductor, the air will become ionized. All right. So now needlepoint here is just to show that there's basically the conductor is a point. It's not, there's other manufacturers or other devices that use a bulb. And then how does the ions get into the space? Basically, they're installed in the airstream. So this slide here just shows an HVAC piece of equipment where the red dots just indicate the 4 different locations of where the ionization device could be installed. Upstream, downstream of the cooling coil, in the fan section, and then also in the supply ductwork. Now, ions are naturally occurring. All these processes out in nature do cause them. They're not harmful to humans. Basically, where the air is cleanest, you have the highest ion levels, and then due to pollution, pollution will cause the ion levels to decrease. Now, how does needlepoint bipolarization by Global Plasma Solutions, or GPS, improve filtration? All right. So back to our 2 boxes with aerosols and gases. So aerosols are basically particles. The chart in the center on the right has gives the size of microns, and then I've highlighted just the percent of particle count. So by particle count, more than 98% of particles are less than 1 micron size. Obviously, something that small is difficult to filter. And then the other problem with these small particles is that they travel deeper into lungs, and then obviously, once again, that is would be considered to be more harmful. All right. So now these small positively and negatively charged particles that are in your space, as well as in your equipment, they end up agglomerating is a term where the positive and negative cause them to clump together. As the particles become larger, they become easier to trap in filters. And then just GPS has done third-party laboratory testing where, based on the particle count in the space, a MERV filter plus the needlepoint bipolar ionization by GBS is equivalent to a MERV 13 filter. And then they also had an application where they had initially a MERV 12 filter. They then added a needlepoint bipolar ionization device, and that became a MERV 16 filter. The 2 boxes at the bottom are just the the standards, or just not the standards, but just the testing entities that these 2 items were performed at. All right. So that's for how GPS increases filtration. How they also improve source control is back to our aerosols. Under microorganisms, we have pathogens. These are viruses and bacteria that cause disease. So ionization, these positive and negative ions attack the DNA structure in these cells, and then they become inactivate and eventually die off. And then just also GPS has done third-party testing of these pathogens and bacteria on the left here. They've been certified by other independent testing agencies. And they have a chart here just showing the test time and then also the kill rate. The kill rate is kind of also called the inactivation rate, right? So what everybody's interested is in obviously the SARS-CoV-2 virus. So back in May, GPS, along with another company, sponsored a testing where they took their duct-mounted product, they installed it with an airflow speed of 250 feet per minute. That's the size of the chest chamber. And then the test that they performed was called like a Petri dish, a sensitivity test, where they basically put the virus in a pathogen. And then the results that they achieved was over 30 minutes. They achieved a kill rate or inactivation reduction where they killed over 99% of the viruses in that little Petri dish. All right. Also with source control, now switching from aerosols to gases, under gases we have both the VOCs, volatile organic compounds. These are organic chemicals that are in vapor form. Some examples are propane, formaldehyde, etc. Not good things. And then just how molecules are held together is by their covalent bonds. There's an energy value called the electron volt potential that keeps these atoms connected together. So the chart here just has a few different chemicals with their formula and then their electron volt potential. One I've highlighted is ammonia. Ammonia consists of a nitrogen molecule with 3 hydrogen molecules. The electron volt potential is 10.07. All right. So GPS reduces VOCs as well as odors by taking that ammonia molecule as it crosses the plasma field. An electronic charge breaks the covalent bonds. The gases are broken down into less objectionable forms, and then what ends up happening is those molecules regather or connect with the other ones. Sorry for the improper science terms, but those individual molecules reconnect to other molecules to make nitrogen or water vapor, et cetera, like that. And then once again, GPS has multiple case studies. One I just wanted to bring up is at the Children's Hospital up in Boston. They had a problem with a construction site that was next door that had diesel fumes. They ended up putting in the GPS device in the outside air intake, and they were able to eliminate the diesel fume smells inside of the the spaces in the hospital. All right. So another thing you have to be concerned about with electronic charges is that ozone. So GPS does not produce ozone versus other corona tubes, which I've showed just a general picture there on the right. So back to our electron volt potential. Oxygen, which is O2, has electron volt potential of 12.07. So basically, GPS's products, their electronic field is designed to basically have the threshold of less than 12 electron volt potential. So that, once again, from that previous slide, the GPS device does not break oxygen into O2 into single oxygens that then could combine to ozone. Now, UL has 2 certifications for ozone generation. GPS product, there's H67, where basically it's 50 parts per million, and then they have UL 2928, which is a more stringent one, which is 10-fold less. It's 5 parts per million. And then just the UL 2998, if your product is certified for that, you get this neat looking sticker that you can shove in everybody's face, that, hey, I got it, you don't, haha. So anyway, so GPS was created or started in 1989. They have over 250,000 installations. They are headquartered in Charlotte. They are in the process of developing testing facilities where they can test their products versus other manufacturers. There's their website. Just want to highlight once again that for HCNI's territory, we're trying to provide these engineering services for all our customers. But just want to point out that GPS is rep by BSS in Delaware. Right. So now the flexibility of GPS, or the needlepoint bipolarization by GPS, is ease of retrofits. So I'm going to show in the next couple slides. Basically, we're not going to go through all these, but basically it can be installed in any type of building. It can be installed in any type of system, any piece of equipment. Some examples are air handlers, fan coils, PTAC units, VAV boxes, et cetera, like that. And then in terms of its location, once again, it's very flexible. It can be installed in the ductwork, on the fan inlet, between the evaporator coil, and then also in the zone diffusers. Now, what's also beneficial to the GPS product is essentially it's very small and very tiny. So going through their product overview from small to large, from 0 to 2400 CFM, you have the IRRIB, which is similar to a belt, like would be installed like at a PTAC type of unit. You have two small generators, FC24 and the FC3. The FC24 also has a self-cleaning device on the wipers that clean the conductor periodically. You can set that up. Increasing in size from 0 to 4800 CFM. There's a duct-mounted product, the DM48 that I already mentioned that was used for the COVID testing. It also has self-cleaning. And then the FC48 is 11 inches by 2 by 3. It also has a self-cleaning device. And then just want to point out that all these products here are UL 867 certified as well, for ozone generation, as well as some others as well. Now, GPS's flagship product is the iMod product. It's shown there in blue with the power. It basically, can go up to any size. They come in 6-inch increments. Very easy to install. They, universal voltage, so it's very adaptable for your existing electrical service. It can be located indoors or outdoors, and then they also have a self-cleaning device. The picture in the lower center just shows the blue iMod product, connected to attached to a cooling coil. Can be up to 240 inches wide. And then the great thing about this iMod product is that they have achieved the higher UL certification of 2998 for ozone generation. You can actually search on the internet for the UL 2998 companies that have achieved that, and find the iMod product. All right. Now, not just the generating, but they also have the sensoring and measuring devices. Up left is the iDetect that's installed in plenums or air handlers, unit mounted. The iMeasure on the bottom is for space mounting, and then they also have the iMeasure D for your induct. You can see all of them are relatively small in size, and then once again, all of these products have the ability to tie into your BAS system. All right, and then just as a side note, HCNI also reps burner air curtains. Recently, Burner introduced a pure package air curtain that has a GPS, FC24 ion generator, needlepoint bipolarization generator inside of it. All these options available for heating, motor, and then also for controls. All right. So now that's enough for NPBI. Let's switch to UVC lights. Once again, we're going to emphasize, kind of system applications trying to apply, how was mentioned in the epidemic publications. All right. So UVGI is synonymous with UVC. Just basically 101. Once again, you have happy little sun there that's creating your electromagnetic spectrum. In the center there, you have ultraviolet light. Excuse me, ultraviolet light is broken down into 4 categories. One that we are concerned about or just will apply or focus on is the short wave, the C wavelength that goes from 200 to 280. Basically, UVC lights are used to kill or inactivate microorganisms, and then that 254 is the preferred or just the ideal spot or optimized for the application. Just once again, generally how UVC light works against bacteria and viruses. They absorb the UVC light, it changes their internal structure, and then once again, the viruses and bacteria can't reproduce, become inactive. All right. So now, ASHRAE and other societies, I'll call them, have a lot of information about UVC, UVGI. They have decades of use, lots of research, just searching up. It's impossible to kind of be super up to date just because there's so many articles and such like that. To help with UVCGI, ASHRAE has created 2 standards to test their lights, to test UVC lights on how effective they are to inactivate microorganisms. And then just today I highlighted the two application or two sections in the ASHRAE chapter, ASHRAE books that are shown on the left. Those were the books that I used primarily for my presentation today for just general information about UVC lights. All right. Just how does UVC work against microorganisms? Just pathogens have different susceptibility to UVC. They're given a K value. This chart is from ASHRAE. Just it shows from left to right, least susceptible to most susceptible. You have floors, and then I've just tried to highlight that viruses are on the right. So viruses are considered to be very susceptible to UVC light. I just want to kind of, cover myself or just say the ASHRAE standard once again just mentions that there's a wide range of K values for viruses. And then once again, why we're all interested today is that about obviously the COVID pandemic, but just a general statement is that because of the newness of the novel coronavirus, UVC light, from what I can see, has not been tested. But all the UVC manufacturers and publications are just saying that because of previous testing on the original COVID virus and this structure, et cetera, like that, UVC light should be effective against the new coronavirus. All right. So how much UVC energy is needed? Basically, your dose or your effectiveness is your the amount of energy per area times the length of time. Items that affect the irradiance or intensity are the distance away. The further that your light is from your surface, you have diminished capacity. The lower your air temperature is, the less capacity your UVC light produces. What's also affected is surface reflectivity. This would be like on the interior of a duct or an air handling unit. The greater reflectivity of like aluminum versus galvanized steel would have an increase in capacity. And then the other thing you have to be aware of is just UVC lights degrade over time. What I found is that, typically the manufacturers talk about 9,000 useful hours of service, and then there's a range of reduction or degradation that the light has over its original input. I've seen numbers from 50% up to 85%. Right? So just with ASHRAE, what I can see is they seem to strive for a 90% kill rate, but then, looking at the publications and testing and research and this and that, it always seems to be much higher than that value, right? So for HVAC, there's 3 methods of applying UVC. The upper right shows a upper room / air system. In the center on the left, we have HVAC coils and ductwork, which we're primarily focused on today. There's 2 types. There's irradiation systems. And then the second type is considered to be on the fly, where you have disinfection of the airstream as well as the aeration or the surface. All right. So upper room air systems typically are installed in hospitals, healthcare. Obviously, you're seeing much more use of these. You have a UVC fixture that's actually exposed in the room. It's shining its UVC rays or light in the upper area. As the air circulates, as the viruses, et cetera, that are in there across this disinfection zone, they become inactivated. Those UVC lights have louvers on them, so they don't damage you, damage your eyes and such like that. And then typically they're installed 7 to 9 feet above the ground. All right. So now we're going to go to your surface coverage with your coils and equipment, how much UVC energy is. This is a typical installation. Typically, the lights are installed approximately 12 inches away from the surface, all right, from the surface, sorry. And then due to longer exposure times, you're going to need less UVC output, right? So going back to our ASHRAE handbook, they have some very low numbers where it's less than like 1 watt per square foot. What I've seen the manufacturers recommend is to use, a range of 5 to 7 watts per square foot. And this basically turns into 1 row of bulbs that are approximately, all changes, depending on application, but approximately, 30 to 36 inches apart. All right. So that's just for surface coverage. Now, if you're going to do on the fly where you have surface coverage, plus you want to kill the cooties as they travel past your airstream, once again, how much UVC light is needed? The difficult part, or just what ends up happening, is that you still have the same concerns with temperature, reflectivity, and lamp output, but now you've added an airflow component as well as an exposure time. So basically, with on-the-fly systems, is that because your virus is exposed to the UVC light for a shorter time, you have to increase your output, right? Once again, going back to the ASHRAE handbook, if you read the standard and convert the watts, convert the output, they basically have a range of 1 up to 10 10 watts per square foot. A rule of thumb from UVC resources, once again, using an approximation of 500 feet per minute, which is very common, obviously, for cooling coils, HVAC systems, comes out to approximately 15 to 20 watts per square foot. So how do you accomplish that additional output? You basically you reduce your spacing between your lights from, say, from 30 to 36 down to, say, 18 to 24 or so. All right. So where are these on-the-fly products going to be installed for the UVC lights? The most common is downstream of the cooling coil. It has the benefit of affecting the cooling coil as well as the drain pan. The downside of that is that the colder temperature has a lower intensity. So obviously you would overcome that by increasing your capacity. Item 2 would be upstream of the cooling coil. The benefit is that the warmer temperatures has a higher intensity. The downside is that you're not going to be effectively cleaning the drain pan, and then you're also going to lessen the effect on the cooling coil. And then the third spot would be in the ductwork. Obviously, the downside of this is that it's not working in the equipment. And then also, too, you would obviously have concerns about installing it and accessibility, et cetera, like that. All right. With UVC lights, you have concerns that your filters have to be UVC resistant. The light can also damage existing liners and gasketing. ASHRAE has a nice chart showing the A to D resistance rating of a bunch of different materials. And then it's also damaging to human as me being Irish, going outside in the sun in the summer with my, with my skin tones, and then also eyes. And then also too, with UVC light, you have just safety considerations, is that you have to really train your personnel. You have to be aware that the bulbs do contain mercury. So there's procedures for disposal as well as breakage. And then because it's damaging to humans, you should have auxiliary devices with door interlocks. And then there's a couple pictures of some safety stickers that you should apply to your equipment. All right. So the products that UVC Resources has available, once again, kind of their flagship product is the RLL Extreme. It's, doesn't have reflectors. It has a 360-degree distribution that helps with the output. They can provide the mounting material, electrical, et cetera, like that, the control panels. What's nice from my perspective is that they have a computerized selection program. You can input your CFM in your face area, and then it's a little bit small, but basically the program will spit out a few different choices for how much UVC light you want to have for your output. Two other lesser or smaller devices is they do have a stick one for rooftop units called an X Plus. They also have for smaller terminal units a 24-volt stinger, shown, a picture of a, kind of looking stinger thing right there. All right. Okay, so last couple slides. So we've talked about the epidemic publications. Also in the recommendations, they talk about auxiliary HEPA filtration units. Just HC9 represents Magic Air. Magic Air has a horizontal indoor air handling unit that goes from 400 to 4,000 CFM, can achieve very high total static pressures. Those choices for different auxiliary heating and cooling. There's a two-stage pre-filter with a MERV 8 and MERV 13. There's an option for a final filter, whether it's MERV 14 or HEPA filters. And then in addition, we have some indoor air quality options for antimicrobial liner. You can factory install UVC lights as well as the needlepoint bipolar ionization by GPS. All right. So now coming very to the very end. All right. So our summary. All right. So today, part one, talked about the epidemic task force. SARS, the COVID virus is more than likely caused by airborne disease. You should try to use HVAC systems to combat its spread. One of the items was to increase your filtration effect, but then they don't want it to cause temperature and humidity problems, all right? So improving your indoor air quality by filtration, some choices that you have that we presented today. First would be to use needlepoint bipolar ionization by GPS. We believe that, versus implementing a higher MERV filter, you could more easily implement the units, the application, won't spend as much time on evaluating, gather information. And then we found that it's very inexpensive to install these products versus implementing higher MERV rating with filters. All right, and all the other potential changes obviously that could occur. We also have auxiliary HEPA filtration units, and then the last item is just improving indoor air quality by source control. Once again, to use needlepoint bipolar ionization by GPS. It will reduce VOCs as well as odors, and then it will reduce pathogens. I underline reduction. And then the second option that is available is UVGI, and then that would cause pathogen. And then I highlighted inactivation just because I feel that the UVCGI does a better job at reducing or inactivating more pathogens versus the GPS product. All right, and then just this is what we talked about today, and then little salesman-ish, little teaser for part two on Tuesday, October 27th. We're going to once again talk about the two publications. We're going to first look at part two is increasing ventilation by increasing your outside air. That would more than likely talk about more replacement work than today was retrofits. And then the last item, or part three, I think I got the wrong date in there. That's actually Thanksgiving. So we won't be doing it Thanksgiving, I'll guarantee you that. It should be the 19th. But for part three, we're going to talk about energy recovery systems, once again, how they apply to the two published documents, the guidance by the ASHRAE Epidemic Task Force. Okay, so okay, let's bring on the questions. Let me escape. Here comes the fun part.
Hey, Jim, this is Tim. I assume you can hear me?
Yes.
Okay, so we have one of the questions was on the COVID test with respect to the needlepoint. And they said if the test was performed at 250 feet per minute, how does that relate to 500 feet per minute? And AHUs are typically 500 feet per minute. What is the effectiveness? And in the ductwork can be up to 2,000 feet per minute. What is that effectiveness? So do you have any comment on that?
Yes, my understanding is that the lower velocity used for the GPS product, the greater the ion production. So so that test was essentially, the partner that GPS did the test with is a company in South Carolina that produces IAQ solutions for the airline industry. And so that test was geared more towards the use of GPS in airplanes. The HVAC system serving airplanes.
Right. So so the second second follow-up question that is by the same person, does that mean you have to resize air handling units and oversize the cabinets to achieve 250 feet per minute?
I would say not to do that. The GPS product is size per CFM. I would not, that seems like a, I'd say a waste of money, but just, you're gonna have much larger equipment, you're gonna need more space, as well as, gonna have higher first cost.
Right, and I can follow up briefly on that. Is while there's a greater production at 250 feet per minute, just because of what it is, that it's not really a true statement. It's not greater production. That's just the range of where they were. At higher velocities, you get greater distribution, so the effectiveness in the space is higher. It's just that's what the salient point where they needed it tested for by the people that were testing it. They were concerned at 250 feet per minute. 500 feet per minute, where we have done in the spaces, we have, where we find that as you increase the velocity, you get a better distribution within the space, you get more effectiveness that way.
Right.
Okay. Second question, or second line of questions, is someone wrote, I understand that most 1-inch, 2-inch, 4-inch pleated MERV 13 filters are electrostatically charged to achieve this efficiency and very quickly lose this performance to become a true MERV 8. Most true MERV 13 filters must be 6 or 12 inches deep. They call this a MERV 8 rating. Can you talk about this some?
I think the question is stating that the MERV rating with the GPS is due to an electronic charge on the filter. I don't find that to be correct. There's GPS is charging. The GPS product is installed downstream of the filter. And so the ions travel in the unit and then the space, and they agglomerate the particles, and then the particles come back to standard filters. My understanding is that HVAC systems typically don't have filters with a charge. I will say that this air ionization system is different than other systems. At a previous employer, we used to rep a different electronic air filter, and the way that product worked was you would install this device similar to like a filter in a air handling unit. As the air entered this device, the first plate would charge the ion negatively, and then downstream you would have a second plate with the opposite charge, and then that second plate would be the one to capture the to capture the particles. So I think the question is sort of referring to those to that type of device where it's still considered to be an electronic air cleaner, but
I think the question, maybe I can say this, is that they're saying just generally MERV 13 filters achieve this by being electrostatically charged, not meaning what any system that we're talking about here. I think that I think that's why there are electrostatic filtration out there. I think the filter media that's being produced by the filter manufacturers that are just, I don't think those are electronics charged. I think a MERV 13 filter is a MERV filter, and it's not achieved that with electrostatically charged. So another question is, any opinion on, boy, I'm going to screw up this word, photohydroionization units that create oxidation plasma consisting of hydroperoxide, superoxide ions, and hydroxide ions. So do you understand the question?
Yeah, to be honest with you, I'm aware of the technology. Obviously we rep GPS, and so you look at what other manufacturers or vendors are proposing. To be honest with you, I've looked at the literature, and I don't completely understand the science of how it works. So I don't want to
Yeah, if I could step in on this just briefly. Number one, ASHRAE recommends, just generally, they don't recommend a technology or manufacturer or a particular thing. Their only thing that they recommend is that you would any product that you would be interested in purchasing and investing your time in would be rated with a UL rating 2998. And so right now, that's you want to take a look at that. I think the hydroperoxides, I think these are things that are, I want to be very careful. This is my understanding. I'm not representing ASHRAE or medical community in this, but these are things that people are, they frown upon for in this space and for, around humans. So again, that's my understanding, and they have issues. Now, there's no doubt about it, the hydrogen peroxides will kill viruses, but they're also very unfriendly to humans. Superoxide ions and hydroxide ions, again, the critical issue here is that you want to be careful of ozone in production of this type of stuff, and the plasma that does this there is a byproduct and certain things you want to be careful about. So without knowing specifically and being able to talk about products specifically, I do know that there are concerns. That's why there's industry ratings, and then there's also industry warnings against certain byproducts that come out of this. Two last questions here. One is cost, and I'll briefly address that. Please just reach out to your HC&I representative for any of the things that were discussed about costs. They'll be able to help you on this. It's it's just too broad of a conversation to have, depending upon application and product and everything else that goes with that. But I thank you for that question. The last one is, when you this is to you, Jim, when you discussed UV light and the appropriate square footage, was the square footage based on the size of the coil?
Yes, yeah, the ASHRAE is talking about when the numbers. Let me just scroll back. Pass it. Whoops. Okay. Yeah. So just ASHRAE. There's I guess two values that I didn't clarify. So in the ASHRAE standard, they're referring to like the watts per square foot that should be on the surface to disinfect or to disinfect the virus. The numbers that I'm talking about are the output of the actual UVC light. The difference in the two values is to try to cover the items in the lower left-hand corner here about the distance away, the surface reflectivity. They also talk about you should size that output that I previously showed. That's assuming that the bulb reduces by 50% or some value.
Okay, I believe that's it. And we appreciate everybody coming in and taking a part of this at your lunch. And please, drop Jim an email if you need PDHs for this. And we look forward to seeing everybody, at least virtually, in a few weeks as we do the part 2, where we talk about dilution, increasing ventilation. All right. So have a great day and have a great weekend. It's beautiful outside, so go enjoy that.
Okay. Thank you, everybody. Thanks once again.
Take care.